for sure. Good to see you.
Hey, we're starting to use it. But the reason I want to talk about this is we might want to do a meeting together like this one. A lot of the guys that work our shop in the same groups anyway.
Oh,
So
cool.
I think there'd be some kind of a cross.
Yeah. Well, when are you, or like, what's the focus of the meeting?
It's JVM is, you know, it's all job
Right.
server side.
Right.
But there's so much, you know, when you go over for the hub, and it's like, you go over into the other areas, that a lot of you guys are using.
Relevant there, yeah. Okay, gotcha.
So,
Right, yeah.
anyway, so
And manufacturing
right now
level,
we're
right.
probably gonna launch, doing this soft launch, I'm guessing that's going to
Okay.
November, somewhere in there, and then I should do a hard launch. So
Okay.
I'll be sending.
Okay.
And I don't, do you know, she knows you, but do you know Caitlin at all from Montana?
Wait, what's her last name? Is it Caitlin Parker?
Yeah, just
Because I'm pretty sure I know, I think I know who you're talking about, blonde hair.
She's a little bit more.
Yes, yeah, I know who she is, yeah, okay.
Yeah, she knows you.
Yeah, okay.
So, she could be.
Okay. Okay. Well, just so that you're aware, we don't usually meet in November or December because these always hit like the holidays, but.
Yeah, well, we're gonna do a soft, we're just gonna get for a soft rollout.
Yeah, exactly.
For practice,
Sure.
get that thing
Yeah.
going, and then, but when we do the hard roll, I'm guessing it'll be half a year.
Okay.
Yes.
Sure.
Oh, hey, how's it going?
Yeah, yeah, definitely, yeah.
I'm saying Sarah.
Close enough.
Oh, yeah.
Besides,
I'll be joining me here. So,
what was like that?
I haven't seen your ass. Maybe you should look. And I'm like,
I gave up, man. I ran out of juice.
yeah.
Did you like, did they at least like do future things?
Like having equity.
Yeah.
Which one do you think was next best?
There was somebody that wrote
Shelby.
Shelby, good to
Nice
meet
to
you
meet
in
you.
person. I know we
Yeah.
chatted a little bit. Hey.
Yeah.
Have you
so-
been out to the meetup before?
Yeah,
Or you
last
just-
time I went.
Okay, the one I wasn't here, of course.
Yeah, you were out of town or something?
Yeah,
or
yeah, yeah.
Deciding family stuff or
I
something.
don't know what I had going on. I can't remember now at this point. It's been too long.
You just made up an excuse not to come.
Probably.
Wasn't that it?
That's probably it.
Well,
Yeah.
it
well,
was
thanks for coming
enjoyable.
out.
So, yeah.
Yeah.
I got the last access code. Oh, yeah. Did I get the password?
Actually, so they were short on those. So they told us just to use the main network. So I can announce what the password is.
I think the password is Death Star.
I think it is Death Star.
I don't think the password is Death Star. See, that's kind of like Death Star.
The Death Star has the center of gravity.
I see how that's connected in your mind. That doesn't make it right, though. Oh, yeah, I don't even need this. I should have taken one. No.
Yeah, it's
I
really
don't
weird.
need someone to be happy.
I mean, like, it technically stays, but I don't really trust it.
I guess I'm
If
just
I
gonna give
nudge
it back.
mine, I found out almost the hard way.
Yeah,
I'm on table.
it's weird. Maybe I'll just grab one of these things. So they have this podium here, which is new to me. It's kind of weird. So like the laptop doesn't feel very secure to me. I'm not going to use it because it's. You can see how it's just this like little tiny thing. So it kind of like slides right off. It's weird.
Maybe if I stare at longer again, I won't actually want to eat it. And I'll get my pillow myself.
So
You can stare at mine if you want.
Oh, thank you.
Marshmallow experiment shows off.
all right.
Look, you can't just talk about the marshmallow experiment for every facet of life, okay? What percent chance do I have of you to come? It's a little more stable. Very little chance of back. Must be the first time my computer's nice.
I would do that, but I think I might look a little silly with it.
Oh, you might need to do
Shots of water. It looks like every single day, it's like working from
Not real
my
life. But slider would go this way, this way. Ladder goes this way.
that's true.
I don't think you can call that a slider.
maybe to the back. It's clear, maybe.
Definitely. I told you, floor above me. But his actual office, I don't remember. Luckily, I have no excuse whatsoever.
Did you look at the weather for this week though?
I don't understand what this.
Still starts raining.
Oh.
That is still kind of hot. But it's back into today level.
All right, we're gonna go ahead and get started in just a minute. People are still getting food, which is fine. If you're trying to get on the network, they normally have a guest network, but they're out of cards, so they said just to use their normal network. So that's the information if you need it. Cool, welcome to the meetup. Thanks for coming out. Here's some information if you're interested in any of this stuff. We're on Twitter, we're on GitHub for slides. We do actually have a live stream option, so if you're ever, at home, can't make it, but you're interested in the topic, we have live stream. We post our slides online, and if you're interested, we have a Slack group as well. So lots of discussion there. So follow that link. And again, the slides are online, so you can get to all these links afterwards if you need them. So if you're new to the meetup this month, it is Bleeding Edge Web. So what we like to do, my co-organizer Corey right here, he and I kind of trade off doing our Bleeding Edge segment. So we sort of talk about latest and greatest browser updates, interesting framework news, stuff like that, that's generally interesting to front-end kind of web app developer types. Occasionally we have lightning talks, so we do have one lightning talk this evening from Ted. And then our main talk is the peer-to-peer web, which I'm sure all of you saw. So Paul and Tara will get up here after that. Before we get into it, so actually, if you've been here before to the meetup, you notice that the room has changed a little bit. So Capital Factory is kind of going through some changes. They added all the space downstairs and all that. So the table configuration is a little different. Also, normally there's someone at that desk all the way through till the end of our meetup. I think after 8, that guy's leaving, and the only people will be like downstairs somewhere. So if you parked in this building, please go right now before you forget and get a parking validation from that guy. I've forgotten to do it several times, and it costs like $30, which is really annoying. So don't do that. We also, a group of us normally walk a block over to 6th Street, go to Buffalo Billiards and chat about stuff afterwards. So if you're interested in that, we'll do that. And then if anyone has any announcements, we normally like to open it up before we get started. If anyone is hiring, or if you're a developer or something looking for work, anything like that is fair game. So do we have anything like that?
Hi, my name is Claire, and I am a front-end developer right now, and I'm looking for a job. So if anyone has one to offer for somebody who's very self-motivated and hardworking, then ask me for my contact information, and I can give you a resume.
A web developer or?
Yes. Primarily JavaScript, Node. I'm working with working on a frameworkless single-page application, if you can believe that. No Angular, but I'm willing to do that if necessary. But yeah, so.
Maybe you can give a lightning talk on that. I'm sure it's fun. Anything else? Yep. And we use the microphone because if anyone's watching online, they'll be able to hear you.
We work at MaxPoint, and we are hiring some principal-level software engineers, more on the back-end focus, but feel free to find us after and chat a little bit more about what we're working on.
Did you guys provide the pizza?
Yeah, so they stole my thunder. I actually have a slide for you guys next. MaxPoint is here. Actually, Capital Factory, thank you for the room. And MaxPoint sponsored our food and drink. Did you guys have anything else you wanted to add other than your hiring?
Come find us after and chat with us.
So if anyone is looking, and tell us a little more about what you guys actually do.
Sure. We are, I like to explain us as a data science company in the ad tech space. So we have some teams working on some really cool stuff. The team that he's working on is working with like enormous amounts of data, and we're able to make millisecond decisions using our systems. And then we have another team that's more like hardware, RF, FPGA focused, dealing with a lot of interesting stuff with like retail shopping.
Sounds cool. And thanks again for the pizza. We really appreciate that. Yeah. Any other announcements? Cool. And obviously, if you think of something at the end, we can shout it out. So thank you, Max Point. Okay, let's dive right into it. So news from the bleeding edge. We normally like to start off with the browser update in case anything interesting is going on. So actually not a ton interesting, and even the Chrome update, I almost missed it because it just happened officially yesterday after I had already done these slides. So actually in Chrome, nothing like super interesting. The one thing I'll point out is this budget API. Has anyone heard of this? The person actually working on browser stuff has heard of it. Anyone else? So the API itself isn't maybe super interesting in terms of like broadly speaking. Most of you guys won't care about it because it serves a fairly specific use case. It's really around making background processing, task sharing, and memory usage more efficient. The reason I brought it up as an interesting thing to talk about though is I'm sure this has happened in the past, but it's the first time I've noticed sort of a significant API released in the browser that is a little different. So like in the past, you know, of course, in the early days of the web, browsers just threw all kinds of stuff in the browser because there weren't standards. Eventually, we had standards and things started to get better. We had prefixing and that kind of thing. Well, in the last few years, a new kind of approach to that is this group called the WICG, which is sort of part of the W3C, but it's not like an official part of it. It's more like a community group that's kind of under their umbrella. And so it's this whole kind of forum now for people, like actually anyone in this room, if you come up with a good idea that you think could be an interesting browser feature, you could actually propose it through that group. And if it's good enough and if people rally around it, it could actually become a spec at some point. And so this is an example of something that just in September of last year, so it hasn't even been a year, this Google engineer popped up and said, hey, we should have this API to do whatever. And they had discussion about it. And then he published it in May as a spec, and now it's in Chrome. So it's kind of interesting, like you kind of should take it with a grain of salt because it's not actually a standard and it could potentially change. But that process is kind of interesting. So it's almost like an unofficial approach kind of in between full W3C standard and just browser specific. So I thought that was interesting. Also, Chrome put out a new platform status page, which if you've seen Microsoft's one that they've had for a couple of years now with Edge, Chrome now has a pretty cool page where you can look at features by version throughout their history. You can also look at like the list of all sort of JavaScript and CSS modern features and figure out like if they're not implemented yet, what's the plan to implement them, stuff like that. Pretty useful. Firefox 55 is still in beta, so we normally don't talk about the browser updates until they're sort of at, stable channel. So I threw a few things up there that are kind of interesting things that we'll probably talk about more next time when they're officially released. One thing I thought that was kind of cool was this WebVR API. So if you're following along with WebVR, you probably know, obviously, it's becoming a pretty big thing. It's also moving to the web. So if you weren't familiar with that, that might be an interesting thing to kind of check out and just see what's going on in that space. Also, this shared array buffer and atomics, I'll come back to that in a minute. So Edge 15, we talk about Edge a lot. It's the confusing one because Edge sort of releases, but it's tied to Windows, so they don't actually do major releases of the browser until like the next version of Windows is going to come out. Internally, the one that's been released to Windows Insider people, they've already upgraded to Edge 16. It just hasn't been released publicly yet, so it's kind of like in beta, essentially. So they've done a few interesting things. Again, you'll notice the shared array buffer and atomics that I just mentioned. That's also available in Edge 16. So I will actually talk about that a little more in 1 second. The other ones are interesting too, but I'm not going to spend any time on them right now. Safari 11 is actually in preview as well. So we used to talk about Safari as the new IE because they never updated. Well, for the past year, they've actually been updating, which is great. If you're a Mac user, if you have actually downloaded the, forget what they call it, the purple icon version of Safari, the preview version or whatever they call it, they've been pretty good about updating that like kind of every month or so. With the next version of Mac OS, High Sierra, that's when it'll be officially released. And they normally do their releases of the OS in the fall. So that'll probably be within the next month or two. Pretty cool stuff here. So WebRTC, if you do anything peer-to-peer, specifically around sort of like video sharing and things like that, WebRTC is really useful. And actually some of the other browsers have already been supporting it. So this is a really important update in that area. WebAssembly, one thing that stands out here that's kind of specific to Safari is this WK Web View. So you may be familiar with web views from iOS, been around forever. So now in the new version, apparently they have APIs that allow you to use web view APIs, kind of like browser rendering APIs in the browser, which is kind of meta and kind of interesting. So I don't know all the details about how that's going to work, but that might be something to check out if you're interested. Cool, so we have this kind of catch-all, languages, libraries, and frameworks. That's a lot of stuff. It's really just sort of interesting things that we've seen in the last month. So one thing that's really interesting if you're a JavaScript developer is the latest version of the spec came out. So if you're an old school JavaScript developer, you probably know that like back in 2000 or 2001, the W3C basically said, okay, JavaScript is done, and we're done. And then they sort of moved on to XHTML and all this other stuff that they worked on for years that ended up being dead end. Well, in the year 2015, you know, the JavaScript world sort of became reinvigorated, and we had ES6/ES 2015. Became all confusing. They're still doing that. I wish they would pick one or the other, but that's what it is. So the new version of that just came out end of last month after our last meetup. So just to touch on a few of the highlights, string padding functions, you know, kind of specific but useful if you need them. Object.values, again, it's kind of useful. It gives you an easy way to iterate over the values of like object literals and arrays and strings and anything that's basically iterable. And then the inverse of that, object.entries, gives you key value pairs as arrays. Again, being able to iterate over objects and arrays and things. Object.getOwnedProperty descriptors basically gives you a way to kind of inspect functions and objects and get metadata about what they are. Pretty specific, but if you need it, pretty useful. Trailing commas, very exciting news for everyone, I'm sure. This is something I could have used 10 years ago when I was still supporting IE6. Not so useful nowadays, but you know, whatever, they added that to the standard, so that's cool. And this one is really useful, async functions. So basically, I'm not going to go through this code specifically, but the bottom line is it gives you the ability to call asynchronous functions without blocking. So essentially, if you implemented something kind of like this, then you could write code like this, where normally you would expect to get Meetup, you know, without a callback attached to it or a promise or whatever, you know, you would expect it to be synchronous. So the cool thing is you can write asynchronous code using synchronous kind of coding style. So you can do stuff like that. So again, I'm not going to get into all the details of it here, but if that sounds interesting to you and you haven't done it before, you should check that out. And finally, the thing that I pointed out on the browser update in a couple of browsers, right? So the reason that that's interesting is because it's actually part of the new spec as well. And a large push within a certain area of the community is around making the web like a more serious platform for things beyond just web stuff, right? So when it comes to like actually building real applications, potentially like what we think of today as things that would require C and stuff like that, Actually, on one of the previous slides, I think on the Safari slide, it mentioned support for WebAssembly. So that's a good example of that same area of the technology where people are pushing for being able to build really sophisticated, high-performance apps on the web platform. So that's kind of what this is all about. This is, you can think of this as basically providing people a way to implement multi-threading type patterns using web technology, using JavaScript. So again, I'm not going to get into all the details of it, but it's in the spec, and because it's been in the spec for a while, even though the spec just got finalized, of course it's been published for a while. So the browsers have taken this one pretty seriously, and they've all implemented it. So you'll probably start to see, well, you'll definitely start to see the web platform maturing in this area in terms of these really sophisticated high-performance apps being built. A few interesting releases. If you use Prettier, actually, who uses Prettier? Anyone? For JavaScript formatting? Not too many people. So if you do a lot of JavaScript, you should check it out. It basically removes all discussion about code formatting. You just sort of let it format your code, and then you don't have to argue about indentation and stuff like that. They just added support for these additional things, which are useful. So if you're not using it, if you do a lot of JavaScript, check it out. Redis 4.0, again, probably not everyone here uses Redis, but that's a really major update. So if you are using it, or if you're thinking about using it, this is the time to kind of check out what's going on. SAS 3.5, if you use SAS, they've added some cool features. They're actually moving toward a pretty major release, which is going to be 4.0. So this is sort of a stepping stone release for them. But again, if you use SAS, you should check that out. And then I ran across this Apollo server, which sounds pretty interesting. So I'm not personally using GraphQL right now, but I'm really interested in that technology. If you're not familiar with it, it's kind of a new take on, like, instead of doing RESTful APIs, it's a way of making more consolidated APIs where you do like one call and you do like a graph search and get back a graph of data. So it's a different way of thinking about making API calls. Anyway, it's really interesting. So if that sounds interesting, check it out. Security. So this isn't technically like a security thing, but it is related. If you're not familiar, there's this service called Let's Encrypt, free SSL. One of the reasons maybe not to have been using it is that up until now, up until this coming January, they didn't support wildcard domains, wildcard certificates. Starting in January, they are going to do that. So free wildcard certificates. So basically, they're trying to make the argument that there's no reason why anyone should not be using SSL at this point. So if you haven't heard of that, and if you maintain sites, check that out. Has everyone heard that Flash is dead officially? So we've all been talking about it and like predicting it, but up until yesterday, Adobe has never actually come out and said, yes, it's dead. We admit it. They finally did. So that's cool. So they're still supporting it through the end of 2020, but as of the end of 2020, no more updates. They will not offer it anymore for download, so it's official. If you are sentimental about it, which I have to admit, I'm a little sentimental about it. So there's this eulogy that's actually kind of nicely written. So if you're interested, go read that. Now for something completely different. Who needs a PHP to JavaScript syntax translator? So I ran across this tweet, which I love the tweet from the guy who wrote it. He said, this is probably the stupidest project I've ever done. So it's basically, if you want to be able to take PHP code and use it on the client side in the browser and have it transpiled to JavaScript, this is the project for you. So pretty random. Upcoming events. So this is something that came up just because it's actually here at Capital Factory, and it's kind of an interesting topic. So there's a training regarding building voice stuff for Alexa, and it's actually free. Last time I checked earlier today, it was still free. So if any of that area sounds interesting to you, you might jump on that while it's still free. So again, that'll be here at Capital Factory next month. And that's all I got. Does anyone have any questions about any of that? Cool, thanks. So we're going to turn it over to Ted for a quick lightning talk, and then we'll get to the main talk. Thanks. Co-working.
Maybe?
So we work on applications and they have lots of huge parts. And one of the problems we've run into on big applications is on JavaScript projects, normally you're forced to bundle everything together. And we've been working on 2 projects where we've had to unbundle things and basically create discrete bundles of logic that we view as async components. And so I wanted to just show you how we're doing it and what we're doing it with. We use Vue.js as our client-side kind of rendering library. But this is essentially a small Vue.js app. Let me just run it for you. That's it, no frills. It simply just takes a bit of model data and puts it in a title template. And that's it. It just renders it to screen. And the first step in these type of apps is to actually go ahead and actually make that a component. And Vue makes it really easy to do that. So we can just come in with some script and just say component toolbar, and then we place a template in for it. And then actually we can come in here and just do toolbar. And so now we actually have a component that's wrapping toolbar. And then that value is being transcluded into what's referred to as slots. So you can kind of see it right here. This title will basically render into this. But that custom tag is now on the client. And it's not that big of a deal because we've just kind of transferred where this is. And I can do this and just say this is embedded. Okay, and if I run this, it'll basically just say, hey, I'm the template tag, but I'm embedded. But the next step is trying to take that component and move it outside of the app and have it be loadable when it's used. So there's no strings attached. If we use the template, it'll basically externally load it and load it in and just run it. And so what we end up doing is the syntax stays the same, but this syntax gets removed. And let me show you. And this is a library that I wrote to help support us doing this. It's called Mull. It'll probably be on NPM in about a week. But with Mull, what we can do is we can basically define that the toolbar is external. And the syntax is fairly similar, but what we say is view component, the component's toolbar, but you're going to pull it externally. And it's going to pull toolbar.js, which is on the file system outside. And mull.get is how you retrieve stuff. And mull.set is, let me show you. Mull.set is how you publish something into that system. So you use get to load, you use set to populate the instance in memory. So from a distributed point of view, once that component loads and it's registered, it'll register back into the framework and then it'll render to screen. So you don't have to do anything other than initially render where the component is going to be pulled from, and then you can use those templates. So you could have, for instance, 20 to 40 screens. All the screens are independently external. And as they're used, regardless of where the user is, if they skip right to template or screen B or screen C, it will only load screen C and any of the dependencies that screen C has. So you don't have to have this monolithic runtime. And what we've ended up doing is putting just our model and some of our base logic, and then everything else is externalized. So let me actually run this, show you what it's like. And if I run this, it's now, so it's not embedded anymore. It's asynchronously loaded. And if I actually go into developer tools, and I can show the network. So it's actually making a request. It pulls index, it pulls CSS, it pulls view, it pulls mull, and then it pulls toolbar because it's used. And just as easily, we can begin doing some interesting things, which are you can begin integrating some other external components. And in this case, I have a small form that I'm going to populate. So essentially we have 2 externalized forms and then 2 uses of those components. And in this one, we're actually passing in title as a dynamic property from the data model. So you're actually pushing it into the component. And then when you run it, it basically runs externally and everything loads. And in the form component, we can simply just say title. And then we come down and just create a prop for title. So that wires in the ability for us to pass data in here. So save. And it'll run it again. And you'll basically see it's passed in view, async view. But that's it. It's a simple library, but go ahead and think about eventually you'll have to break your application out into smaller parts. There's lots of different ways to do it, from Webpack to other things. This is how we do it. Thought I'd share. Thanks.
I haven't done that yet. Let me see what I can do with that.
Yeah, so it's just co-working is the Apple thingy. No, sorry, nothing.
I gotta get on.
Yeah, and just co-working and it should pop up there. Cool. So while Paul and Tara are getting set up, does anyone have any announcements that they thought of while we were waiting? Any comments? Any jokes?
What's going to happen to homestarrunner.com?
Oh, no.
Somebody needs to preserve that.
I don't know that one. Someone help me out. I don't know the answer to that.
It's
You can,
sliding.
yeah, you can
No
try it. I don't know. Sorry
I'm not
about
gonna be able to do the demo right down there. What do you feel like doing?
I'll make sure.
Hold this. Probably not right in front of it.
All right, this should work. Would you like me to use the mic?
No, you're fine. It's mic'd right here.
Well, hi everyone. Today we're going to be talking about the peer-to-peer web. My name is Tara Vansel and this is Paul Frazee. And together we form Blue Link Labs. And at Blue Link Labs we make a browser called Beaker. Now Beaker is pretty similar to the browsers that you're familiar with, but it's also quite a bit different than other browsers. And the reason why is that it's a peer-to-peer web browser. And we'll explain exactly what we mean by peer-to-peer web in a little while, but I first want to explain what our motivations were for building a new browser in the first place. So to understand why we were inspired to build a new browser, you have to understand at a base level how the web works. And I imagine that most people in this room are pretty familiar with how the web works, but I want to make some observations that might not be obvious. So let's define the definition of what the web is supposed to do. The web is supposed to be a network for sharing documents. And documents are applications, they're websites, they're images. They're pretty much everything that we send from computer to computer across the web. And the web is, right now, very good at getting these documents from one computer to another. But the web is actually more than just getting documents from place to place. The web is so interesting and rich because anybody can publish documents on the web, and that's a core piece of what makes it so valuable. So the original designers of the web made an assumption when they conceived of the web, and that assumption was that it would always be easy for anybody to spin up a server and publish a website or publish a document on the web. And that assumption has not stood the test of time. If you think about what it takes to set up a website, you have to buy a domain name, you need to set up a server somewhere. If you're feeling really fancy, you could actually buy the hardware and set up your own server, but that's pretty expensive. So most people instead, if they want to do it themselves, they'll rent hardware and then run the server themselves. But think about it, that still requires a very specific skill set. And even for people who have that skill set, it's pretty burdensome. So most people, when they want to publish anything on the web, this includes status updates or messages to their family and friends or photos that they want to share, they do it through someone else's application. And they use someone else's server to do it. So this vision of independent publishing has been lost on the web. And what we see instead is a centralized model where most of our interactions on the web happen through someone else's service. So it's not enough to say that we've lost the original vision of independent publishing on the web, because for what the web was designed to do, which is get documents from one place to another, the web is actually doing a really good job of that. It's pretty cheap and easy to do that right now. So I want to explain exactly what we think is problematic about the fact that independent publishing is not easy. The first thing that we lose as users by having independent publishing be easy is privacy. So I think if there's anything that every single web user can relate to, it's that unsettled feeling of knowing that companies like Facebook, Google, and Microsoft harbor so much of our personal data. And unfortunately, we can't really do anything to fix that given how the web is currently built, because we depend so heavily on applications that aren't ours and that are run on servers that aren't ours. So in order to connect to other people on the web, we almost always go through some middleman, and we don't have any practical privacy from those middlemen. The second problem with the web is something called data silos. And a data silo is a symptom of the application architecture we use on the web right now. Like I mentioned before, most of our interactions on the web happen through a middleman. So if you're depending on a middleman to access an application, then that middleman is in an interesting position where they can sort of lock you in to using their application. So if you think about how identities work on the web today, you might have multiple accounts on multiple different websites, and each of these websites and the companies that run them are incentivized to keep you on their website. They're not incentivized to let you take your data and move it to another similar application. And worse yet, the data that you use on their applications is not actually yours. It's theirs. That's the bottom line. So for example, if you were to break the terms of service of one of these applications, like by not using your full legal name on Facebook, they could terminate your account, and the reputation you establish on Facebook would be totally lost. You can't transfer that elsewhere. So this just seems a little bit silly, because what it means is that we as users aren't really empowered to control our own data, and the companies that harbor our data have a lot of control over what they do with it. So both of these problems stem from the fact that it's difficult to publish independently on the web. And Paul and I realized that, and we were thinking about what it would take to solve this problem. What would it take to make it easy and cheap and fast to publish on the web? And that's the core of why we decided to build Beaker. Now, what did we do with Beaker? What is the special sauce of Beaker? Well, we took the browser, the main browsing experience, which is looking at websites, using applications on the web, and we decided to build a peer-to-peer protocol into the browser. Now, you might be wondering, what does this offer to the web experience? Well, what it's enabled us to do is make it possible to publish and host websites directly from the browser without needing to set up a server or pay for anything, for that matter. And that turns out to be really powerful. So I don't want to dive into the details of how we've implemented the peer-to-peer protocol in Beaker, but I want to talk a bit about what a peer-to-peer protocol is and why it endows us the ability to do this inside of the browser. So if you've heard of BitTorrent or maybe used BitTorrent, you probably know that a peer-to-peer protocol is basically a file sharing network, but something that's special about it is that it's distributed. So peers on the network don't just download files, they also upload files and help rehost files onto the network. So it's basically a community network for contributing bandwidth and sharing files. And it's also important to point out that anybody can publish on the peer-to-peer network. It's very easy for peer-to-peer software to allocate domains, if you will, and for anybody to publish at a domain that they control. And that's a really important part of what we're doing. So let me step through an example to demonstrate some of the unique qualities that peer-to-peer networks have. So let's say you have a file and you want to share it with a friend. What you do is just start hosting the file on the peer-to-peer network using some software, and then give the URL to your friend. and she would be able to download that file directly from your computer. And that's the most important part about it, is that the file comes directly from your device. There's no third party involved. And that's why it's called a peer-to-peer network. Now it gets even more interesting when you add in more peers to the swarm. So let's say you have another friend and you want to share that exact same file. Again, you share the URL with her, but this time the new friend can download the file not only from you, but from your other friend that already has the file. And she can download it in chunks. So this means that file download can actually happen pretty efficiently. And of course it gets even more efficient as you add more peers to the network. So there's this interesting property where even if a file is really, really big, or if you have a video that goes viral, a peer-to-peer network can scale up to those demands of both large files and high demand. And it can do so without putting any burden on one specific user. And that means hosting becomes very cheap. The cost can be pretty much zero. So that's what we've done with Beaker. We've taken a peer-to-peer protocol called DAT, and Paul might mention a little bit about that later, and we've built it directly into the browser so that you can publish websites and host them directly from your computer without needing to set up a server. And with that, I will hand it over to Paul, and he'll show a demo of what we've built.
Cool. Okay. So this is Beaker here. Cool. We built it with Electron, if anybody's familiar with Electron. It works very similarly to what you would expect out of a browser, so we can open up a website. There's lots of different tabs you can open, and you can bookmark pages and zoom and unzoom and all that sort of stuff. So very familiar from the outset. That's good. Familiar is good. You want to start from something that everybody knows, but let's go over to the Beaker homepage real quick and get into the peer-to-peer stuff. You'll notice over in the top right corner, a little tag, peer-to-peer version available, showed up there. We have a little bit of magic in the background, which I could explain in the QA if you're curious how that happened, but it has a way of knowing. And I'm going to click on this. What you should do is watch the HTTPS over in the corner and the word secure, because that's the only part that's going to change when I click on that. Okay. So we just went from the HTTPS version, which is centrally hosted, to the peer-to-peer version of this website. Now, other than the fact that we've changed protocols, the experience is more or less the same as before. We still have the same short name. We can click around and find different pages. There's HTML, JavaScript, embedded images, and all that sort of stuff. So the basic core experience is more or less the same. But we have this peer-to-peer protocol, and we can open up this inspector, which is specifically designed for this protocol to look at the internals. So this is kind of like dev tools for the peer-to-peer network right here. Now, the way this protocol is designed, again, it's called DAT, and I'm happy to go into it later. It's actually not developed by us. It's developed by another open source team. You actually exchange entire archives. And the archive is addressed by a public key, and here we're using DNS to find the public key. And then included in that archive is a file listing. And then from there, we choose what file you might be interested in. So when we go to beakerbrowser.com, we want the index.html. So it pulls down this file listing, finds the index.html, and that's what we see, right? So that's kind of neat, first of all, because we have this whole file listing. We can look around and explore it. So if I want to open up the images folder and find, how about my picture of the team listing, there I am. Or there's Tara, right? That's kind of cool, right? That you're able to see all the source code to this thing. In fact, why don't we jump over to the JavaScript folder here, and here's some of the JavaScript we're using. There's the code for the sidebar, for instance. So that's a nice way to be able to explore a website. Kind of a cool feature of it. From there, let's take a look at the history tab. Now, an interesting quirk of the DAT archive, the way it's designed is that every time you make a change, it actually gets recorded in this history. And that history is made available to you through the protocol in this log, and we can actually explore, and every time you make a change, like writing a new file or anything like that, it updates the revision number. So we can scroll through this, and this is kind of like your Git log, but it's for what you actually publish. So why don't we scroll all the way back to the beginning, the very first file that was added. Interesting thing we can do with this is we can actually click on these links and go back in time. And this is the first revision that was published to the site. There was just one file. Of course, has to start somewhere, so it published this file here. And this is some metadata that's involved in the protocol somewhere. But if you look up at this URL here, you see this little +1. It's kind of hidden away. It's not very obvious. But that is the version number right there. And we could move forward in versions, and let's choose a random one. Hopefully this won't totally... Yeah, there we go. That works. So there's some more files in it by the time we get to revision 150. So yeah, you can basically move through the history, and that's a really cool feature for something that is a data set, or maybe even more importantly, like JavaScript modules. To actually have the versioning in the protocol, you can peg onto a version and say, I want to hold on to this one in particular because that's the version of the stuff I trust and I use. Or maybe if you want to go back and see if somebody's trying to change content on you. So versioning is built directly into the protocol. Now let's step back to the home page. One other thing that I'll point out before moving on is that because we have this full listing of all the files, we can actually choose to do this button right here. This is adding to our library. And what this is telling the browser is, okay, we know all the files that are in the site. We know all the assets. Why don't you just download all of them for me? And then if the network ever goes down, I'll still be able to access the site. So we can click add to our library. Now I've done that previously, so there's no download flow here. But now, if I open up the library view, we'll see right at the top, there's the Beaker browser. Here's the file listing. And this is kind of like looking at the GitHub page for a site, right? We're seeing the file listing, and there's that history. Here's the network. And it looks like there are 5 other peers on the network right now hosting it, which is great. And if my network were to go down, I'd still be able to access the site. But once the network goes back up, I'd be able to resync any changes that may have happened since the network went down. And now we have this nice availability guarantee. So basically everything I've showed you is just some neat features of the protocol, a couple of different advantages that come built in with the peer-to-peer system. Well, let's get into what Tara was talking about, which is publishing websites. So to do that, we just hit this button here. This is probably something that you haven't seen in a browser before. Ability to create a new site. Works more or less the way you'd expect. Reading, set a title, give a little description, create the site. Okay, we're back in the library now. This is a place for us to begin working on the site. Why don't we add some files to it? And how about this guy right here? You got your computer on? Cool, okay. So it's going to confirm that we want to make this change to the site, and yes, we do. So we'll hit publish and open up this file here. And just like that, we got a little cat pic. And up at the top, we have a URL. That's a big URL, we'll grant that. 64 characters long is the domain, but this is totally unique. And this URL I can share with anybody in the world that's able to actually, create a connection to my computer, and they'll be able to download it for me. So we're going to go ahead and try to live demo that part of it. I'm going to send the URL over to Tara, who's sitting here, and she's on the Wi-Fi. Now let's see.
There we go. Just opened it.
We promised we didn't do that ahead of time. The really neat thing about that is that just happened right over the LAN, right? So we didn't have to talk to a server at all. There could actually, if we wanted to, we could take down Capital Factory's internet connection, and that still would have worked. They may complain about that, but. So something to keep in mind just before I move any further is that these are all just files on my computer. I can click open folder here, and it's going to open it up in the Finder for me at some point. There we go. And here's the image that I just added to it. And then dat.json is this little metadata file. It's where the title and the description went after I wrote that down, right? And I can actually work with it from this directory. So if I just delete this thing, go into the trash, go back and recognize that a change occurred, right? So I can review the changes, and it's saying, hey, look, that protocol stack.jpg got removed. So I could choose to publish it because I could say, yes, let's go ahead and put that deletion out into the network, and that's the new state of the site, but I don't want to do that. I'm going to revert. I can then actually revert the files and restore that picture back from the grave. If I go back to the Finder, you can see it was restored from the history. And that's one of the advantages of the versioning system, is that you can restore back in time. But file sharing is cool. Love to share cat pictures, but this is a browser, we need to have websites, so let's get some HTML in there. And there we go. Works exactly the way you would expect out of a website. Index.html gets loaded up when you go to the root directory. And so I could share this with anybody, and it'll upload right onto their computer. Now, we're developers. We know what it's like to have to build these sorts of applications. Let me pull over my Sublime editor real quick. We happen to know that live reloading is pretty valuable, so we decided to throw that in there as well. This is not like the most important feature, but we like it. So if I click this little lightning bolt right here, turns on live reloading, and I can go back over here, and I can stick in some more exclamation points and save. Automatically reloads for me. A cool thing about this is, I'm not going to be able to demonstrate it right now, but this actually works over the network. The way this peer-to-peer protocol works, if I were to go ahead and publish these changes, anybody that's in the swarm with me would actually get pinged about the fact that the content changed. So this lightning bolt would cause the page to refresh on their computer as well as mine. One other thing I want to show, just because, folder. Speaking of features that just make me happy as a developer, we have native markdown rendering in it. And that was just one day I was bored and thought, wouldn't that be nice? So threw that in there as well. All right. Okay, so we've demonstrated now the basic idea that we were talking about originally, which is you're able to publish websites off of your computer. And that's very cool, but that is not actually what people do in their day-to-day experience with the browser. You don't really make that many websites usually. What matters more to people is applications. And the model that we've started out with for solving that, the kind of key idea that we want to go with is how can we get away from using servers to do everything? If we have to publish to another siloed database, then the ability to make websites is only so interesting. So the first thing that we've done is exposed all the different capabilities that I've shown, the ability to read files and write files, the ability to check the version history, things like that. Those are all exposed as an API, a web API, which applications can access to be able to access the same capabilities we've seen so far. And there's probably no better demonstration of that than this code editor application. Before I open this, you should know that it does sometimes crash the browser. So let's all hold our breath. So this application we actually originally built into Beaker, but we've decided at one point that it was a little bit too opinionated, and editors, people are touchy about editors, so building it into the browser felt wrong to us. But we took all the code out, and I recently was able to put it back in as a just data application, so it's totally in user land here. And just to give a good demonstration of it, oh, there it is. Of all my times of actually giving the demo live, that's the first time it did crash on me while I was doing it. So.
Still better than Adam.
I'll take it. Let's try it again. Yeah, no, it did. So let's try to look at the index.js. Made it. And I just wanted to open this. We're actually looking at the index.js of the code editor itself. So we're doing a little self-referentiality here. You know, I'm using Monaco. If you're familiar with Monaco, it's actually the, if you know VS Code, this is the same editing engine that's inside of VS Code. They've very, very nicely decided to make that open source. So you get the nice mini map and a nice programming experience, so that's cool. So why don't we open up the site that I just created, turn back on the live reloading for a little more fun. Now, we have ways to make this work better, but at the moment I have to manually copy and paste the URL in, which is not the coolest, but there you go. So now we're looking at the site that I created earlier. You can see the title there and the little description I made. And I can open up the index.html, and there's that HTML. And why don't we do, Now, I'm going to hit the save button, and it's going to ask me if I want to allow this, right? Because what I'm doing is I'm editing one site from another site, right? You're going to need to ask for permission for this. I'm going to say allow it. Oh, our live reloading didn't work. That's a shame. Make a bug report about that later, but the edit did work. So what we demonstrated there is the foundation of how at least a certain class of application can be written, because this DAT archive, or excuse me, this DAT files API can act as a sort of a data substrate for both reading and publishing and editing data, right? And in this case, we're doing direct, HTML modification of another site. But you can actually imagine doing things like publishing something similar to a tweet or making a photo album where you're actually writing images in JSON to publish the actual content that you're creating. And the really neat aspect of this is that it's all being done locally. The DAT archive API is simply an API that's controlling write access to this hard drive, right? Just a local files API. And you can make these changes even if you're offline, and you can publish them, and then once you go online, you can sync it out into the world. Right? So I got a couple of other applications that demonstrate that. One of them is called the WYSIWYG. This is a little wiki app, and this kind of app is what we call a self-mutating app. It's called self-mutating because it's going to use the DAT archive to modify its own files. Right. So mutate, change, and self, you know what that means. So let's do bleeding edge wiki. Now, I'm going to press the edit button here, and some of the software that's just built into the website now opens up this nice editor. And we'll do that. Now let's say hello world. And why don't we give it some cool styles? Make it a little bigger, and why don't we center it? Cool. And hit save. What we just did is modify the index.html. Because if I refresh the page, it's actually going to change the page itself, or it's going to that content is going to persist. And then if I publish it, it'll then be available onto the network. So we used the DAT archive to modify just a section of the index.html. Make sure that we didn't destroy any of the software that allows me to make these edits, but the content of the index.html got changed through this API. So that's the self-mutation. And why don't we inspect the site files real quick? And I just want to show you a little bit of what that looks like. Open the folder. Is Finder going to play along today? Yeah, there it is. So here's what that looks like. There's that content that I wrote right there. Right? So we just make it, set it up so that whenever you make the change, we write the main.ht, the main tag, but then the rest of it stays the same, doesn't get touched by those edits. So that's the self-mutating website. Finally, I'll show a quick photos application. This is something that Tara wrote the other day. Pretty simple application. Demonstrates something a little bit more, the kind of application that you'd want to use on the internet. Create a new album here. The way it's set up is it's actually going to make a new website for the album. So we'll call this My Cat Pics. And we'll add some photos to it. Okay, and actually we're done. I can hit this share button here. It gives me the URL. This URL, just if you open this URL up, it's the same URL that we actually have up in the URL bar right here. I copy that, paste it somewhere, and we have this nice little photo album. Right. Go back to my album listing. There it is in my listing. And then if I inspect the site files, you'll see the way this is structured. You got the index.html. That index.html was written by the Photos application when it created this new website. So that's how we have this nice presentation for it. The images were written under the images folder. Pretty straightforward. And then why don't we go ahead and look at the source code of this app. Have we broken it? Nope, we didn't. And you see all these links, right, to style sheets here, and there's probably a script tag down there. Yep, right down there. these are all references not to the current application. If you look at the current app, it's got this C72D44, that's the beginning of the URL. But this is F0ABC, etc. And that's the original Photos app. So it's actually cross-domain linking the JavaScript and the CSS that provides the presentation here. So this site right here is nothing but presentation. It's the index.html that you have to have for the site to load, and then it's the specific assets, and then the rest of it is just linking back to the original domain to provide all the presentation logic and the styling. So this is sort of where we are so far. The idea that we have is that, again, the data archive API, these APIs for this peer-to-peer system can make it possible to write applications which aren't just comparable to existing applications, but at some point we think can actually go farther than the existing sort of architecture for web apps. And one of the huge advantages of this is that it dramatically reduces the amount of operations work you have to do, because we didn't have to create a service to run any of these applications. This is all a bunch of JavaScript and HTML and CSS just interacting with web APIs in the browser. So if we wanted to make a new application, or for that matter, if we wanted to just fork this current one, go up in the URL bar and fork this site. Watch that URL up here. Oh, yeah, it's going to work. Tempted the demo gods. There we go. We have a new version of the site that's in my control, and I can just open up the source and start making changes, right? So all the source code for these applications are being downloaded on my computer, so I can start to make changes for them. And ideally, we can get all the business logic in here, so that if you have an application that you use and you want to make a change, all the data is on your computer, all the code is on your computer, this is open source, and you can just work with it, right? So that's the big idea that we have with this. And the Files API of this peer-to-peer network provides a good substrate, right? And we're currently kind of seeing how far we can go with it. What kind of applications can we make with it? And you've seen a couple here. We think we can also make a pretty good Twitter clone off of it. The stack is not complete, though. There's going to be things that we need, like the ability to aggregate and do big queries across the data network, right? Like, has anybody mentioned me recently in my little social application, right? That's kind of hard to answer unless I'm crawling over the entire network and looking at all the files. So that's an example of something that'll be down the road. The ability to establish a direct connection and send, chat messages to somebody, that should be easier. We don't use WebRTC in this, but it's kind of hard to set up those connections right now. But once the stack is really filled out, we think that it might be possible that you just don't need services anymore. You can have a web experience that's completely peer-to-peer.
With your Twitter one, can you elaborate on your web crawl, the point and uses of the web crawler?
Yeah.
And how that might appear to something outside of that Twitter? I'm just kind of glancing at the wall.
Yeah, you saw the thing I was talking about that? Yeah.
Can you repeat the question?
Yeah, so he's asking me to elaborate on the crawling idea real quick. So what we have that works really well is the ability to exchange files. And so if I know the URL that I want to get the file from, it's no problem. The network is designed to help me find whoever has the thing. So let's say this cat picture here. I have the URL, I can download it off of one of the many peers on the network. That's no problem. But let's say that in this social application, everybody's publishing these tweets, and they're just JSON files that they're publishing to their own websites, right? So every one of them has a /tweets folder on their social profile site, right? And every once in a while, somebody will publish one that mentions the URL for my profile site, right? Because they're mentioning me. Right? So they did @pfrazy, and that maps to my personal site. I would like to know that that happened, but let's say things have gone really well for us, and there are billions of people using this thing, right? Well, I, as a personal user, my laptop can't sit there and download everybody's website in the entire peer-to-peer network, right? That's just not going to work. But what you can do is set up services somewhere that actually kind of work like Google. They sit there and they crawl all these peer-to-peer sites, and they ingest them and archive them away. And then look for, I'm a user on this service, they're looking for mentions from my site, right? And then they say, okay, yeah, that's for Paul. Let's create a little database somewhere and note that this site has a mention of you. They put that in a place that I could do a GET request to. Right? Now, this would be a service-based model, but they're talking to the peer-to-peer network. So this is this openly available data network. And they're crawling it, and they find any time that I'm mentioned, and they can tell me, let me know that that happened. Now, The way that that is significantly different from the way that websites are currently done is that it's still operating on the publicly open data set. Right? The peer-to-peer network still is unsiloed because each user is in control of their own sites. Right? So they're crawling across this publicly available data network. And why that's really important is that, let's say I'm using some service out there called thecrawler.com to do this. And eventually I decide I don't really like them that much and I want to set up my own server at home that runs its own crawling software. I could set up that crawling server at home, have it start to index the network, and switch over to it, and I don't get any disruption in my experience. Right? The data set is unsiloed, it's open. So there's no lock-in to that original thecrawler.com. I can switch over to my own instance, right? Now you need to have a server resource because it's not feasible for my laptop to do that crawling, but the ownership of the data itself is still very public domain, still very open. So that's how that is conceived in our minds so far, but we haven't actually gotten to the stage that we've implemented that. So, you know, with that, we might as well just get into the QA, because that's the demo. Yeah?
Is there any thought about executing in the data archive, meaning from the services point of view, being able to publish JavaScript and basically returning services from those?
Would this be like you write some JavaScript into an archive, it syncs up to a server, the server automatically starts running it inside of a node process sandbox somewhere? Is that what you're thinking?
I guess I'm just trying to, I'm struggling with just thinking that everything in here is kind of like working with a giant zip file.
Yeah.
And everything's just static.
Mm-hmm.
So how do you make it dynamic without forcing everybody into that rewrite? You know, could you create a service that was running between two things? And one of we have JavaScript VMs and machines, so it's easy to do interpretive stuff.
Well, you can still make requests to external services, just like before. So it's really not all that different than developing applications on the web right now. It's just that in addition to what you have on the web right now, there are these APIs for writing to the user's file system and reading from the user's file system, which is something we don't have on the web. And so it makes it possible to build applications that store the user's application data. So like Paul said, their tweets or their likes or whatever, you can store that on the user's device itself. So you can still have dynamism because it's pretty much just like the web right now with a few extra APIs.
So there's still approaches, you can blend services into this thing.
Yes.
Mm-hmm. Absolutely.
Yeah. You had your hand up, I'm sure.
Maybe I missed it, but how does the addressing work? How does it, the equivalent of DNS in this deal? How do I know where things are?
So first of all, I'll explain what these big URLs are, and then I'll explain the DNS bit. I think I may have mentioned this before, but these big URLs are public keys. So the way the system works is it's cryptographic addressing. This is a, if you're familiar with the kinds of crypto, this is an elliptic curve key. 64 characters long, it maps to 32 bytes, so it's hexadecimal. I own this site because I possess the private key that allows me to sign updates to it. For the DNS, you saw that with Beaker Browser site. DNS is a little bit tricky. We can't just use DNS because DNS is not secure. It's easy for somebody to sit on the network and pretend that they're the DNS server and send me bad answers. That is one of the reasons why using HTTPS is always a good idea, because HTTPS gives you an added level of security that you know that you got, or within some amount of certainty, you know that you got the right address and the right server for an address, right? Now, we don't have the equivalent of an SSL certificate for the DAT protocol. So what we did is we sort of cheated. We bootstrapped it off of HTTPS. So we have a normal server that is serving over HTTPS, serve a file at that location. So if you're looking, if I go to dat.beakerbrowser.com, then what the browser does transparently in the background is asks for HTTPS beakerbrowser.com/.wellknown/dat. This will trigger a download. And you can see I've done this at least 3 other times. And that pulls down a file that kind of looks like a DNS entry. What we have is the address that beakerbrowser.com should resolve to, and a TTL. Right. Does that make sense? Do you see how that protocol works?
Almost. Don't we have to get to an IP address somewhere?
The HTTPS protocol does that. So what happens is when I go to dat.beakerbrowser.com, in the background the server contacts HTTPS beakerbrowser.com. That does a DNS lookup. We then speak to the HTTPS beakerbrowser.com, whatever that IP address is, and then we get the .wellknown/dat file, and then that tells us what the peer-to-peer address should be. So we have to basically bootstrap DNS off of centralized servers for the moment. That was the best compromise we could come up with for the moment. It is relatively easy to deploy, and that was a pretty high priority for us. We looked at, if anybody's familiar with DNS security, DNSSEC, you might want to check it out. It is an alternative version that we could use for this, but its adoption has been really poor, and so we felt this would be a good enough compromise for the time being. By the way, this is how we had the magic of knowing that a peer-to-peer version is available. Every time the browser goes to a site, it just looks for that file and then caches whether or not it found it. So if it finds that file there, it says, oh, hey, there's a peer-to-peer version. Right. So that's how that works. Yeah?
So is the content encrypted by default?
Say again?
When the data goes over the wire, is it encrypted by default?
It is.
Yes. There's actually an interesting property with the URLs. So if you think about the Photo Albums app, when you create a new album, that actually creates a new website. And so what's cool about that is the traffic's encrypted using that public key, the public and private key pair. And so only people who know this URL, which is a private key, can actually discover and decrypt the content of the website. So you basically have secret file sharing built into the protocol.
Second question is that you mentioned it's distributed. Now, how do you prevent somebody else from changing the sites, your content?
So each of these URLs are public keys. They're public keys. And so you have to have the private key so that you can issue an update that you sign.
Okay.
Yeah.
And what keeps say from getting previous versions? I mean, you've got a version history of your web page on there. Say you're offline and whatever, someone else is hosting two versions ago. Would that kind of propagate if like the most recent version of the site isn't available, or you're like?
If the most recent version was not available, you would get the most recent version that is available. Yeah.
Can someone force propagating out an earlier version?
No.
No.
Look at the beakerbrowser.com blog, the most recent blog entry. The most recent blog that entry that we have on the Beaker Browser site gets into this particular topic in pretty good detail. I don't want to get into it now because it's pretty weighty, but the blog post is pretty good. It explains exactly how these updates are propagated, and also talks about some of the security attributes of it, which are really interesting, but a little bit out of the scope of this talk. Yeah.
So you said that if you wanted to see who was mentioning you on a sort of a Twitter analog, and you wanted to look for names that, mentions of your name, then there'd be a crawler that would go and look for that, even if it's service-based. How would you prevent, like if you're hosting a site, for example, a photo album site, like let's say you're an artist, and that content is crawlable, how would you prevent someone from stealing your work, stealing your data, rehosting it, even as a peer on the network? Is there any, have you given any thought to content control, like maybe preventing sharing your content with certain users, or like having an accepted user list that only these people can access my content, or prevent it from being crawled?
Yeah, so these URLs, they're public keys and they're effectively unguessable if the cryptography is working right. So the network, a crawler that you set up can't actually find your content, could not find your photo album, for example, unless someone else on the network had linked to it. So it would work just like, you know, the Google web crawler does, where it just goes from web page to web page and follows the links that are on every web page. So really the only way that a crawler could find it is if you've shared the URL with someone else and they've published it on a web page on the network.
Let me expand on that a little bit too. You could think of these URLs as being like whenever you use a service and it's like, I want to have a secret sharing link, right? And it's going to mint this URL that's hard to guess, right? And that's a decent base level or kind of simple use case for how you can provide some security. But if we want, what we would like to do at some point is have a stronger guarantee where I could say, I want to make sure that only you can get this, no matter who has the URL. And for that, we plan to implement end-to-end encryption.
Okay.
Yeah.
On the implementation of the browser, so can sites served through DAT access resources over other pragmas, HTTP, HTTPS, and so on?
Yes, it can access, this is actually an active conversation. We just recently set it up so that it can access HTTPS, not HTTP.
Cool. And then does that mean, like, have you experimented with getting pragmaless HTML sites working isomorphically between DAT and HTTP?
We have a server that hosts over both. In terms of like automatically taking an HTTPS site and then like converting it into a DAT site like from the browser. We haven't written that yet, but it's totally doable.
Is there anything about it that would be not backwards compatible if you implemented it correctly?
If it's a totally static site and you're not accessing HTTP, you should be okay. It
So
should.
you're just referencing other files like through relative addresses and stuff like that?
Yeah, it pretty much, in a lot of ways, just to speak to an intuitive level, the most significant difference is the scheme change from the HTTPS to DAT, and instead of an IP address, it's a public key. And in a lot of ways, the rest of it feels exactly the same as before. You just suddenly reminded me that we have a service that's worth showing. This is called Hashbase. This is something that we put up. It's a little community for publishing your peer-to-peer sites, and it actually uploads the sites to the thing. So we have all this different sites that people have uploaded, including my site here, and it rehosted over both HTTPS and the peer-to-peer network. So here's over HTTPS, my personal blog, right? So in case somebody doesn't have Beaker yet, they can still access it. And then over peer-to-peer, just like that. And the main reason that we, and you can see I got a nice short URL there. Main reason that we did this is because you have to turn your laptop off sometimes, and if your content's not popular yet, you may not get a guarantee that it's going to be available because my computer's the one that's hosting it's off. So Hashbase is like a nice super peer that's up in the cloud that you can push up to keep your stuff online. You still retain the signing keys. You don't have a silo effect at all. It's just another peer that you can command to rehost for you. That's that. Another question, yeah.
You mentioned your code is based on Electron.
Electron, that's right, yeah.
Electron. Does that pose any limitation for future features?
That's a good question, actually. Not in a way that like seriously concerns me in any way. As we get more ambitious, we'll probably need to we'll probably need to fork Electron at some point so that we can get more access. But basically, Electron, for anybody that doesn't know, Electron is Chromium. Chromium is, Chrome's internals. They publish it free and open source. And so Electron has taken Chromium and wrapped it in a JavaScript API. And basically what they've done, they did it originally so that you could make a nice little desktop application using the web platform. So for instance, the Slack application, the desktop application for Slack is written in Electron. But what they also did was basically dramatically reduce the barrier to working with Chrome and building a custom fork of it. And there's actually a number of different projects doing what we're doing. The Brave browser, if you've heard of that, that's being run by Brendan Eich, who's the guy that invented JavaScript. Exact same thing. They took Electron and they forked it actually. And so now they're building a browser on top of Chromium using that tool set. I think also Ethereum is working on a browser called Mist. Same idea. In a way, it's kind of like what the Linux kernel did. You can make all these sort of highly opinionated distros of the Chromium core, right? And so ours is opinionated towards peer-to-peer protocols, and in particular, the DAT protocol.
Brian, you have a question?
Yeah, I'm just curious, like,
business model, or just how do you guys plan to sustain it?
Well, we just showed you Hashbase, which is a free and premium model. So you can sign up and get 100 megabytes of storage or rehosting for free, and then after that, it's $7 a month. So that's our model right now. We're pretty excited about this because in addition to being providing availability for peer-to-peer websites, it's also a way to discover other people who are hosting content, which you actually need a service to do this in the peer-to-peer web, because otherwise you'll just have to be, if you want to find interesting content, you need to have your friends like share it with you manually, or we might have to go back to the days of Yahoo where they just literally had listings of links on their homepage. So this is just a fun way for us right now to help people build stuff and make sure that it works for them in the early stages of the peer-to-peer web.
Should we talk about the home hardware?
If you want to talk to us about home hardware at the bar, feel free to do that. That's like a long-term monetization strategy.
Yeah. Wouldn't it be cool if you could just have a server at home that's totally private? You could run search queries against it, and nobody ever knows what you're doing with it. And that's the idea.
Do you guys envision little islands of the own internet besides just now there's Beaker Browser with this sort of core here, and someone else hosting their own little sub peer-to-peer network that's not connected to yours. It's just little islands of internet.
Web rings, if you will.
Well, so actually, I have a question for you. Are you referring to splitting the DAT network, or are you referring to other Electron distros with different peer-to-peer tech?
Second one.
The second one. Yeah. He's asking, do we imagine that other people are going to do what we're doing, but with different technologies? So a good example of that, there's a competing technology to DAT called IPFS that's been created. Anybody, who here is familiar with IPFS? Anybody know it? Tanner, you know it? Kind of know it? Okay. It's actually interesting to know. When you're kind of competing with somebody, you kind of imagine everybody knows about the other guy. Totally feasible that somebody would do that. And actually, our position on this is that it should happen, because what we kind of would like to see happen right now is there's a whole lot of different protocol and technology plays occurring right now. There's stuff like DAT and IPFS. There's also all kinds of blockchain things. There's a lot of experimentation to be done. So we actually think it's a really great thing that Electron is available right now, so that people can do what we're doing. So our official stance is we're in favor of it.
I guess I'm trying to envision something, small pockets of public intranets that are just little isolated communities.
Yeah.
Yeah, you could definitely pull that off. I mean, you could imagine a group of friends, or even maybe a family, running their own server that basically acts as the hash base, but for that little family or group of friends. And that could be their pocket of the internet where they share their tweets and photos and whatever else. Totally
check out the IPOP project for that.
IPOP?
Yeah, peer-to-peer VPNs.
Huh.
Oh, cool.
That's cool. Yeah.
Tell us a little more about that.
Sure. DAT, he asked me to tell a little bit more about DAT. By the way, I just should mention real quick, this is really old school. This is an RSS reader built on top of DAT. So each of these blogs has an RSS.xml published on them. We had 5 of them that we're pulling from, and there you go. That's really old school Web 1.0 action there. 1.5, I guess. Okay, so he asked me to talk a little bit more about DAT. DAT is, first of all, it's being developed by a nonprofit called Code for Science. It's a grant-funded project. It is a variant of BitTorrent. So, show of hands, who here is familiar with BitTorrent? Okay.
Pretty popular software.
Yeah, and Tara talked about how it works, and by and large, and that as people start to download files from it, they'll also re-upload into the network to reshare it. Fundamentally, it's the same model. DAT builds on top of it by, first of all, making it possible for you to make updates to a set of files. So we call it an archive in DAT, but in BitTorrent it's called a torrent. Right? That's the analog. And in BitTorrent, after you publish a torrent, you're not able to make any changes to it. It's just a fixed set of files. And the DAT system, you're actually able to make updates. I mentioned the blog post that talks about how those updates are dispersed. But if you're, I'm going to try out an analogy, and this may or may not work with y'all, but it's actually internally a lot similar to the blockchain that is used by like Bitcoin, except that you only have one entity that writes to it. All right? And so it's this chain of blocks, and each of these blocks has hash references, cryptographic hash references. This is getting pretty nerdy here. But what it basically creates is a system where as you add entries to it, you have this one big number that refers to the entire history of all the changes. And that number ends up representing, oh gosh, how do I talk about this without getting way deep?
I think the core thing to know about how the logs, the internal logs of a data archive works is that it's append only. So you can only ever add changes or deletions to it. But a deletion isn't really a deletion because it's just something that's added to this log. That's it. And you can't ever be taken away from it. It can only be added to. And that allows for this property which gives us auditability. So that's the core of it.
So she saved me there. Yeah, so there's a log that distributes all the updates, and that's what we're looking at when we look at this listing here. And we can find somewhere there's a deletion in here. And we can demonstrate that aspect of it. The log doesn't actually tell us enough information to be honest. Sometimes we're actually adding, and sometimes add really just means updated or wrote. So there's a deletion right there, right? So that log is then sort of used to populate the file listing. So if I say add index.html, add cats.png, after those two events, I now know the file listing is index.html and cats.png. So we take all those events of changes to the log, and then we kind of turn that into an idea of what the current file listing is. And so each of those file listing objects has now, like index.html, there's a content address, a content hash. All right, I'm going to ask for one last raise of hands. Who here is familiar with the content hash, like a SHA-3 or a MD5, that kind of idea? The idea is that you can, it's a mathematical function where you can take a file and get out of it a number. And this number is, with some amount of certainty, going to be totally unique to identifying the file, and you can't go backwards. So you can only go from file to the number and not in the reverse. The interesting thing is that if I say, okay, index.html is the number, and for the sake of explanation, I'll say the number 0. It would never happen, but let's say the hash came out to 0. Okay, index.html is represented by 0. So then you would say, okay, I want index.html. Somebody in the network have index.html, its hash is 0. And I'd say, yeah, I have it, and I'd give it to you. You would download the file from me, and then you would run that hash function on it again. And if the number that came out was 0, you'd be like, oh yeah, you gave me the right file, right? The hash came out the right way, right? So, so that's how we make sure that any peer can give you a file and not lie. That's how we, that's the first part. Second part is every time that I make one of these changes, I sign it with the key pair. So when I said, okay, index.html exists in the world, I'm going to add a signature to it, and you verify that signature when you download it and say, yep, that was by the author. And then you say, okay, I want this file with a hash of 0, and then you get that, you check the hash, and there you go, you know it came from me in the peer-to-peer network. I apologize, that was a little disjointed. But so it is a cryptographic file sharing network, is what it is at its core. And that is why it is able to share files in a distributed fashion.
And so that organization publishes that protocol
yes,
altruistically, or
yes.
They're grant funded, and it's actually pretty interesting. They created this protocol because they wanted to make it easier for scientists to publish really, really big data sets, because that's actually still a difficult thing for scientists to do. And they got a grant, I don't know what their first grant was from, but they've been funded by the Knight Foundation, the Sloan Foundation, to help ease that pain point for scientists. So they built this protocol with that in mind, and it turned out to have all of the properties that you need to build a peer-to-peer web. And so Paul found out about them, I guess, about a year and a half ago now, and started working with them and playing around with what it would be like to have their protocol inside of a browser. And that's how it all came to be. And they're still active. They have, I think, about 5 or 6 engineers right now working full time. And yeah, they're doing really exciting work. They've got an awesome team.
Yeah, it wasn't originally designed to be a web protocol. We kind of hijacked it and we're like, hey, it works for us, so yeah.
Do you need the whole log to display a file?
You don't. There's a nice optimization internally, which makes it so that you can download just segments of the log and still be fairly certain that you're getting an accurate picture. If you want to be really sure, you could ask for the entire log, but in terms of like maybe a malicious actor might be able to trick you somehow, maybe. If you want to be 100% certain that you get the right entry, you can download the full thing, but within an acceptable level of security. You can download a subset of the log, an efficient subset of the log, and just get what you need. Yeah, Tanner?
Does that support like in-style, like merging of trees? Like you can only have a single author from everything I've seen so far.
Yeah.
Are there ways to resolve forks in what are getting published? Like, is there a way for another author, or for one signature to republish a fork under the same name and stuff like that? Is there anything within that or within Beaker to facilitate that?
There's not anything in the DAT protocol. You could do that in the application layer. Right? You could write an application which merges together the things by however you want to do that, and then publishes some piece of metadata in a file saying this is a merger of these 2 different DATs. But at the moment, there's nothing in the protocol that's designed to do that, and I don't think that will ever become a part of the protocol.
So you could have like an editor that could replay the revisions made from a fork over the master or the origin.
Yeah, you could, and you would just have to have like a file somewhere like forks.json that tells you like where it came from, like the ancestry of it or something like that, or the branches that exist out in the network, something like that. Some mechanism of discovering it. The protocol itself doesn't do it. The concept of it right now is more analogous to NPM than to Git, right? It's really meant for publishing a single history as opposed to being a good source control system.
I think there was a question over here.
Yeah.
Yeah, I might have missed this, but how do you decide which peer to get the file from?
For the moment, it's whoever shows. Like how do we do? Are you asking how do we find the peers, or how do we choose from the peers that are available?
Well, yeah. Well, you mentioned that as soon as someone downloads the file on the network, it's available for someone else to load that file from their device.
Yeah.
So how do you decide? What's the algorithm for deciding that?
For deciding which of the people that are uploading to download from, or for deciding who has the file?
I guess both.
Do both.
Okay, both. We'll do both. Good answer. So there's a process that we call discovery, and that basically involves my computer asking a couple of different networks, hey, does anybody on the network have files for this archive that I'm interested in? And so there are actually multiple different ways. There's first of all on the local area network, it uses multicast UDP. So it just broadcasts out to the Wi-Fi. Anybody on the network have this thing, and if somebody responds back, we'll make the connection. Then there is something called a distributed hash table, a DHT, which is originally used by BitTorrent, and that's sort of a mesh of computers. That is, we're getting again into the nerdy stuff, but a really fascinating system for basically you start with a bootstrap node, and then you ask it, hey, do you know of any other nodes that are involved in this thing? And then you ask it if it knows any other nodes, and then you kind of enter into this big swarm of a mesh of computers, and then you can query it, and it's resilient to one of those computers opening and closing. And so the design of this system is sort of like to keep a living registry, where I can show up in this registry and say, yes, I have that archive, and then eventually I turn my computer off and I just fall out of the living registry. And so that's how that happens. Now, choosing which ones to pull from, I actually don't know what they implemented for that choice. I think it probably just tries all of the options and gives it a shot. Yeah, well, actually all of them at once, There's probably some kind of limit, like maybe stops after like 8, and then doesn't try to open up more connections than that, or maybe it's 16. I don't know what the limit is, but it just tries to get enough that it's going to have a good, a performant download.
And so it handles all the chunking.
Yes. Mm-hmm. Yeah.
So you were, I guess, choosing which other user to get your file from. But like with BitTorrent, you're getting pieces from lots of different users. So in this case, is it the same or is it like all from one?
It's the same as BitTorrent. You can get chunks from multiple different. Yeah.
In this case, like clients who are downloading things, there's also like they also contribute by sharing the same content back. Is there any way that you enforce that they actually contribute back?
That's called the leeching problem, because you're being a leech.
Right.
And at the moment, we have no mechanism for that that I'm aware of. Maybe, I don't think the DAG, BitTorrent has some kind of protocol for this. I know that they implemented at some point. And so there are, there's stuff out there that we can use.
Yeah, I mean, the way we do it inside of Beaker is when you visit a peer-to-peer website, you automatically seed that website for a short period. So we're just counting on people being willing to do that during the time that they're actually browsing web pages and applications. We haven't accounted for the leeching problem yet, but we're hoping that people will be nice enough.
It's actually sort of an interesting question whether or not we should force it. Because I think there's a case to be made that some people ought to be able to choose to leech because maybe they can't afford it. Maybe they're using a mobile device, and so that bandwidth cost would be too high for them.
Yeah, why don't we save the rest of these questions for
Are we
afterward?
time?
Or, I see people are packing.
Yeah, we still have time. It's up to you guys. But.
Okay, maybe one more question?
Yeah, let's do one more. Okay, you know what? Who has a question? We got 1, 2, 3. We'll make these our last 3?
Yeah, okay, sure.
4?
I might ask.
Okay, yeah, well, all right. Last 3. Tenor, I know you had one. We'll start with you.
Is there a centralized place for like broadcasts, or like how do you connect to? Well, the network is DAT or is the network Beaker? I don't know. How do you connect to the network if there's no one else on the LAN? Is there some sort of centralized HTTP broadcast, or do you guys maybe use Hashbase, like the HTTP DNS stuff? Like, how do you discover other peers when you haven't discovered one yet?
The DHT has bootstrap nodes, so they're hard-coded starting points.
And are those just like centralized services somewhere? Like
Yeah.
Okay. On the open levels?
Yeah.
Okay, cool.
One over here, yeah.
Just follow up. So are you saying that you are enforcing, or the thing that serves data from your device is the browser? When you're running the browser, you're serving data.
Yeah. In fact, right now I have 56 peers.
So when I shut it off, I'm not serving data anymore, or is there a background?
When it's off, it's off. Yeah. Yeah.
Is it available?
It is. Good question.
On our website, on GitHub, you can get the official application from our website, or if you want to build it from source on Linux, you can do that as well.
Yeah, we don't support Windows yet. Sorry, Windows people. We're not there yet, but everybody else. Cool. Rest of this we can do at the bar.
Oh, I think.
Oh, last one.
I was just wondering, what do you guys see as your biggest hurdles growing your user base?
That's a good question.
There are a few of them. I think getting people, first of all, used to a new protocol is definitely a challenge. I mean, people are used to seeing HTTPS and the green lock next to it. So getting people used to that is tricky. The availability problem is also tricky too, because people, when they make a website and they put it up on a server, when they pay for a server, they expect that it's just going to work. But if you create a website in Beaker and you don't upload it to Hashbase or something similar, and then you turn off your computer, you might be frustrated to find that your visitors can't access the website. So that's a new way of thinking about the web that we have to teach developers and teach users.
Those are good answers.
Yeah.
We can come up with a long list of our deficiencies. I think actually, for my money, it's the apps. I think we need to have a set of apps that are like really easy to use and get you hooked into it, Because like making websites is fun and all, but really we need to have just something you can do in your day-to-day. And hopefully the social thing that we're working on will maybe kickstart that. Yeah. Cool. Thank you, everybody, very much. Appreciate it.
Awesome, that was great. Thanks for coming out. If you forgot to get a parking pass and need one, look for someone downstairs in the lobby. Any last questions or comments before we break? Cool, so we'll be at Buffalo Billiards if you want to join us. Otherwise, have a good evening, and thanks for coming out.
Other than that, I can't really say where else.
Yeah. Well, you were asking good questions.
So. It helps I sit there and read your blog at the same time as you're presenting.
That's on there right there.
Yeah. The other things that I was kind of interested in are, I wasn't really good at forming my questions or expressing what I was trying to get at. Some other thoughts or ideas in there. I think I recently read an article in Wired that could remove that access. One of them was talking about providing web access for kind of communities for people who are just like say government keeping them down like in revolutionary countries or something like that. So there's kind of a way for organize. But I'm not certain if that's but I don't really know if that's quite appropriate or not.
I have mixed feelings about that because there's like two classes of people that like really hear about that. People who are worried about people in like a really oppressed place, and then some people who are kind of like crazy.
Sketchy.
Yeah.
So.
Well, I'll tell you my honest answer to that. We're not military, right? We are better, but if you really like as a state actor, then I'm not better than the military, better than like HTTPS in terms of like it's a little bit harder to shut us down if you get onto a LAN with somebody or a LAN with somebody, exchanging files, but like you can't. That's not really that great of a
I guess the other thing that question I had or considered is have you considered market outside of here? Like, what does this look like, or is this direct equivalent for like places where your internet isn't so hot? Like in India, like if you could take off India this kind of having this peer-to-peer network, and things this could work over cell phones or whatnot, where you have enough, a large enough population and a density that you can work in these kind of small batches. You could probably take off there as opposed to here, with a kind of maybe. In a developing market, your people aren't so entrenched into the ideas of how the web should work, and you can get it to work on a kind of smaller scale, peer-to-peer. That's an active.
No, that's a good idea. We actually have probably the biggest trick is and I think that you really have to be
and it has to work on low bandwidth. But I mean, that's the idea of kind of small pieces that can be distributed. People come and go. There's an avenue there somewhere.
Right, and also the fact that you can like set applications for work off. That can definitely be great. It's a great job. Really, it's just
My name is Paul. So I looked up your website from the Beaker site. One question, so
so as long as I got it on my phone.